Hello everyone, welcome to the 12th tutorial session of problem solving through programming in C. So this is a SWAYAM course which has been floated by Professor Anupam Basu from Department of CSE Kharagpur, and I am Siddhant. I am one of the 3 TAs who are in charge of taking these tutorial sessions, where we will be covering a few questions which will help you out with the final exam. Alright, in tutorial session 11 I had already covered the content for tutorial session for week 12. So in this tutorial session I have handpicked a few questions from the assignments of all the weeks, and I'm going to discuss their solutions. So it will be a mix of things such as recursion, loops, and like the functions, basically everything that has been covered in the 12 weeks of the course. So let us get started. So here's our first question. So the first question is that we have a function which takes an array as an input or as a parameter, and it increments the pointer variable, which is the array variable, by 1, and it prints ARR of 0, and we call it from the main function. We have defined a array of size of 3 integer elements, 5, 10 and 15, and we pass the array that we have defined through the function called fun, and we also print out the 0th and first element of the array. So what do you think should be the output here? So here let me just write down the array. So if we have this AR 5, 10 and 15. Now ARR points to this, which is the first element of the array. Now when you send the ARR to the function called fun, here this ARR is actually it's a formal parameter. This is an actual parameter. So this is what you called an actual parameter, and this is what you call a formal parameter. So the ARR here is the ARR in the function fun is different from the ARR which is in the main function. So even if you increment the ARR by 1, so this is okay, let me write it in a different ink so that so this is also, I have also defined another ARR inside the function fun, which points to the first element of the array, and now I shift this by 1 by saying that ARR is equal to ARR plus 1. I shift this ARR which earlier pointed to the first element of the array to the second element of the array, and then I print ARR of 0. So currently, after doing this increment operation, ARR is currently pointing here. Now if I write ARR plus 0, or sorry, ARR of 0, that basically says that star ARR plus 0. Now ARR is pointing to 10, and I'm asking for the value at that location itself. So 10 is the first thing that gets printed, right? Now the function exits. There is there is no return, but because it's int, it will simply return 0. Now the next thing here is it will print %d ARR of 0. So mind you, the ARR in the main function is still pointed to the first element of the array. It's not pointed to the second element. The ARR which was in the fun is in the function called fun, that pointed to the second element of the array, but ARR which is defined in the main function is actually still pointing to the first element of the array. So when we print ARR of 0, it again basically does this particular print, star of ARR of 0, which gives you 5, which is the first element of the array. So 5 will be printed, and then if you print ARR of 1, so that basically is this, which means the second element, right? So you get 10. So option B is your answer. You get 10 printed from the function here, and then you get 5 and 10 printed in the main function. Is that clear? Alright, so if that is clear, then we'll just go to the next question. So the next question is also based on pointers. So here what we have done is we have defined a string called hello world, and we have also defined a pointer and set its value to the string. Okay, so basically you have this HELLO. Okay, let me write with a bit more space. HELLO, comma, space WORLD, semicolon, null character. Because it's a string, there has to be a null character, right? Now str is a string which points to this, to the first element of this array, right? And there is also another pointer ptr that I'm defining, which is the same as str, which means it points to the same location as that of str. So both of them are pointing to the first element of the array, which contains the value, the character h. Now I print the string, %s is used to print a string, and I print the string ptr plus 7. So what is ptr plus 7? So this is ptr plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. So basically if you calculate, so this is ptr plus 0, this is ptr plus 1, similarly this will be ptr plus 6, which is this empty space, and this is ptr plus 7, which is the w. Ptr plus 7, this is w. Alright, now so when we say ptr plus 7, that means ptr plus 7 actually points to the element which carries the value, that is the value, the character w. Now when we say %s, so it starts printing from this point onwards, and we say it's a string, and the string starts at ptr plus 7. This is what this entire printf statement means, that we want to print a string and the string starts at ptr plus 7. So ptr plus 7 is basically this element which is the character w, and it starts printing from here. And if it starts printing from here, so what will you get as the solution? You will get world and with the exclamation mark, right? The null character is not printed, of course, and then once the null character is encountered, the printing stops. So world exclamation. So our answer here is option C. Is that clear? If okay, if this is clear, then we'll just move on to the next question. So this is a little bit about recursion now. So we have a recursive function. We have a recursive function which takes two arguments, as we can see here. It is an unsigned int n and an unsigned int r. So one, if you remember, unsigned basically means it starts from, whole number, not exactly integers anymore, but whole numbers. So 0 or greater than 0. Okay, and sign means, okay, let me write in this manner, that sign basically means it can be positive or negative, and unsigned means it can only be positive, or 0, of course. 0 can be there in both, sign or 0. Okay, so that is what unsigned and signed means. Signed is the default one. If you just write int, it will consider it as a signed. So this is the default case, which is the signed case. But if you specify it as unsigned, so basically your range, the range of integers that can be represented in the unsigned one is higher than the signed one, because you are in every integer one byte is reserved for the sign, right? The leftmost byte is reserved for the sign. But if you, sorry, leftmost bit is reserved for the sign. Now if you say that it's unsigned, so you don't really need to save the sign of the integer anywhere, so that extra, you get that extra bit as well. Okay, so that increases the number of integers that you can specify by an order of 2. Alright, so let's see this function. So this also returns an unsigned int. So it takes 2 unsigned int as arguments, and it returns an unsigned int as the return value. Okay, now the function, it states that if n is greater than 0, so n is one of the arguments, n and r are the arguments. If n is greater than 0, it will return n percentage r plus it will call the function again with the value of n by r and r. Alright, now the question asks, so what is, so this is written wrongly, this will be func. So what is the value of the function func when you call it with these two parameters, which is 5, 13 and 2. Okay, so let's check that out. So in the first function call, the first call, you have you call 513 comma 2. 513 is greater than 0, so what will it return? It will return n percentage r, which is 513 percentage 2, which is what? 513 is not divisible by 2, so you will get a remainder of 1, right? 1 plus again it will call func. Okay, let me kind of write it not as first call, second call, but as func 513 comma 2. So this returns 1 plus func of n by r. What is n by r? You have now 256, right? So it will be 256 point something, but it's an integer, so it will automatically be truncated. So you get 256 comma 2, right? It will be n by r. Is that clear? And so n was 513 and r was 2. So if you divide them, you get 256. 256.5. The 0.5 is just ignored because it's it can only carry an integer, so the 0.5 part is ignored. So you basically are sending 256 and 2, which is r. Alright, so in this function call, what happens? 256 is still greater than 0, right? So you do n percentage r, which is now 0, and again it calls func 128 comma 2, right? Then this does 0 func 64 comma 2. Similarly, you continue. This goes for 64 by 2, which is 32 comma 2. Sorry, this is again 0 plus this, because n percentage r, no remainder. So again 0 plus func 16 comma 2, then 0 plus func 8 comma 2, 0 plus func 4 comma 2, 0 plus func 2 comma 2, then 0 plus func 1 comma 2, and then you get 1 plus you call func of 0 comma 2. And when you call func, the function func with 0 comma 2, because n is no more greater than 0, it will simply return 0. So this is 0. So here you get a value of 1 returned here, okay, and this is 0 plus 1, so you get a value of 1 returned here, and 1 plus 0 return 1, right? return 1, again return 1, return 1, return 1, return 1. It will keep getting returned because you are adding up with zeros, so the value is not increasing anymore. So you return 1, again here it return 1, and here there is already 1, so you return 2. Okay, so here when you call this particular function with the values 5, 13, 2, you will get an answer which is 2. Is that clear? So it will proceed until n becomes not greater than 0. So that is the point till when the recursion will continue. Once n becomes 0 or lower, it cannot be lower because it's unsigned. So when n becomes 0, so that is when the recursion stops. As you can see, when we called func 0, 2, that is where the recursion stopped because the value became 0, so it returned 0. Now if this returns 0 and it got added up with 1 in its previous recursion, so then it returns 1, and that subsequently gets returned back again and again, and finally we got 2, which is returned to the function when we call 5, 13, 2. Alright, so now that is clear. Let us look at a question where we have to solve this using one segment trapezoidal rule. So if you remember the one segment trapezoidal rule, what we do is if this is the function f of x and this is x, and there is some kind of function like this, and we are asked to take a segment. So here say the value is a and b respectively, and the corresponding values are fa and fb. So we consider this thing to be a trapezoid, and we calculate the area of the trapezoid if there is a single segment. If there are multiple segments, then we take multiple number of trapezoids and we calculate each of their areas and sum them up, right? So here if you go for the calculation of the area of the trapezoid, it will simply be half into the height into the sum of the sides, which is f of a plus f of b, right? So these are the sides, so sum of sides. Now this is the height, which is b minus a, and half of this entire thing, so that will give the area of the trapezoid. So here you have been asked that the function is x into e to the power 2x, and the values have been given here. So a and b corresponding, a is 0, b is 1.5, that has been given to us. Now we are being asked that what is the integration value of this using one segment trapezoidal rule. So we just need to consider one single trapezoid. So we calculate f of a. So f of a is 0, as you can see, and f of b is 1.5 into e to the power 3, right? 3.0. Okay. You can calculate the value if you want. I'll just write the procedure. So now if you calculate the area, it will be half into 1.5 minus 0 into 0 plus 1.5 into e to the power 3, right? So it will be some 0.75 into 0.75 into 1.5 e to the power 3. So whatever this is, this will be your answer. Okay. So they have asked, the question has asked up to 4 decimal places. So you will get numeric choice questions, numeric answer questions like this. So if it has been asked to write it till 4 decimal places, then you have to round it up at 4 decimal place. So they do consider if you don't round up and stuff, but it's always better to round up and write till 4 decimal places, because that is what they have their machines set to take the answer as. So be very careful while answering this numeric type questions. So you have to follow whatever convention has been given which is here it is 4 decimal places, so you write till 4 decimal places. Okay, all right. So now that that is taken care of, let's look at the question. So this is a very common theoretical question that gets repeated each year, which is what is the equivalent pointer expression for referring to the array element. So we have a 4-dimensional array here, which is A, and we are referring to the ijkl array. Now when dealing with this kind of questions, you need to break it down one by one. So let's say this is the first dimension, this is the second dimension, this is the third, and this is the fourth. Right, now I'll start from the first dimension. So we have, if we just write A, that means it refers to the star of A. Sorry, if you write A, that refers to the location of 0 0 0 0. Okay, that refers to the location of 0 0 0 0. Now we want to go by I positions, go next by I positions in the first dimension, by j positions in the second dimension, by k positions in the third dimension, and l positions in the fourth dimension. So accordingly we write A plus I, which is our first dimension, right? This is our first dimension, and we place a star accordingly. Now next we need to go in in the second dimension by j units or j elements, right? So we write plus j like this, and enclose it in another braces, another star. Then we want to go by k units in the third dimension, so we write plus k, again enclose it in another star, and then we write L, so enclose this and put another star. So when we write this basically is equivalent to A of I, of j, of k, of L. Okay, now you can notice that because there are 4 indices here, you have 4 stars here. Okay, now if you miss just the last star, what does that refer to? That refers to the location of this particular element which has been given in the question, the location of that element, but not the value of the element. So if you want the value of the element, there has to be the same number of, you have to put the same number of stars as the number of indices. So here there are 4 dimensions, so there has to be 4 stars. Okay, this is just a trick to remember how to go about this. So you can compare the options here, and option B looks like the correct one. Okay, I hope that's clear. Alright, so let's look at the next question. We have a short type of a short data type, which is basically a smaller data type than int, but it can take integers. Alright, but of lesser range than int. So we have defined short, we have defined an array of size 3, 3 and 2, that means 3 rows 2 columns, and we are setting the initializing the array basically. So we are doing an initialization here, and we are again trying to print something. So this is again pointers that we are trying to print. Alright, so let's see what we are trying to print here. So if I write num, what does that basically signify? So the way that it has been stored in the memory is simply, so here first let me write down the array. So the array is something like this. You have 3 rows and 2 columns, right? So you have 2 and 5, 11 and 17, 23 and 28, right? So this is your num, but in the memory it has been stored in the row major format, which is this. Okay, Now num points currently to this, which is 0 comma 0 of the array. So if you say num, it points to the first element of the array. So 0, 0 and 0 on both indices. Right. Now if you write num plus 2, then what happens? If you write num plus 2, you just move from the first element, you move along the first index, right? You saw this here, right? You saw this example. So how can we write the pointer expression for this? Let me just write the pointer expression for this. So we have written num plus 2. This is already something that we have written. Now again you are adding a 0th index for this. So I'll write plus 0 and put another star, right? So this is the equivalent pointer expression for this first expression. So what happens here? What does that mean? You are saying num of 2 of 0, right? So num of 2 of 0. What is num of 2 of 0? So the third row and the first column, which is value of 23. So you have 23, the first value, and the second value as star star num plus 1. Okay, now let me write that down, num plus 1. So I can rewrite this as star star num plus 1 plus 0, like this, right? I can write it like this. And what does that represent? Num of 1 of 0, which is basically the second row and the first column. That means the value of 11. So 11 is our second output. So here you have option A as the output, which is 23 comma 11, right? Does anyone have any questions? If not, then I'll just move on to the next one. By the way, if you have any questions, you can also write it in the chat box. Okay, so again we have another pointer related questions. As you can see that I'm explaining mostly pointer related questions because these are kind of a bit more tricky. The questions might be a bit more tricky with pointers and recursions especially. So it's better to be prepared for those kind of questions. So let us see. This question gives us when we have entered two different variables x and y, initialize them to 5 and 10 respectively. Now we have two pointer variables which point to the location of x and y respectively, and then what we do is we do star p is equal to star y. Now let us just, this is a simple representation. So you have, this stores x and y, the value was 5 and 10. Now what I did, I defined a pointer p and a pointer q. P pointed to the location of x and q pointed to the location of y. Now I said star p is equal to star q, which means what? The value that the q location holds will be copied to the value that the p location has, right? So basically the value of 10, which is being stored at the location of this pointer q, the value of 10, right? The value of 10 will be copied to the memory location that is pointed by p. So here instead of 5 it will now be 10. It will become 10 now. Now after this what do we do? Star q is 20. That means the value at the location being pointed by q, it is set to 20. So now this becomes 20, right? So now when you print x and y, so as you can see you get 10 and 20 as the output. Okay, this is a pretty straightforward question from pointers explaining how the pointers and how are pointers used, and how you can access the address and the value stored in that location. Alright, now a question regarding algorithms that we learned during the course. So this is related to the as you can see, the array is ordered. It's ordered in ascending form, and you have to basically do a binary search, right? So okay, is that not written? Oh, I see. So you have to do a binary search here. So this is a question pertaining to binary search, and if you remember, in a binary search, what we do, we divide the array into two parts. So that is what we will do. First I'll just rewrite this: 94, 98 and 100, and we are starting with a key of 100. That means, sorry, we have a key of 100. That means that is the value that we want to find in the array, right? And we have this ordered array which is necessary for binary search. Alright, now the question asks that what are the mid values corresponding to the array elements which are generated in the first and the second iterations. Now in the first iteration, what we do, we divide the array. In binary search, we divide the array. So as you can see, this is the array of 7 elements, right? 7 elements. So we take the middlemost element, that is 91, right? And we compare the key with 91. So we check if key is greater than 91. Yes, it is true, the key is greater than 91. So we go to the second part of the array. Okay, I mean, we consider only the second part of the array because we know that the array is ordered. So if the key is greater than 91, that means it must occur in the second part of the array, not in the first part. So key is greater than 91, which is true. So we just consider the array which is after 91. Okay, so the first middle value for our for the first iteration, our middle value is 91. So this is our middle value. Now what happens in the second iteration? So in the second iteration, we consider only these 3 elements. So the middle value we take as 98. So we check if the key is greater than 98, right? It's true, the key is greater than 98. So we go and we consider only the remaining part, which is the only remaining thing. So in the third iteration, we would check if key is greater than or equal to 100, which is the only value left, and we find this to be true, especially not just greater than equal to, but rather we check if key is equal to 100. So and then we find the key. So for the second iteration, the middle value is 98, right? So we can say that the correct option here is 91 and 98, which are the respective middle values obtained in the first and the second iterations of binary search. Okay, I hope that's clear. All right, so okay, let's move on to okay, in the main exam, I think the coding exam is separate. The main exam has MCQ and numeric answer type questions, and yeah, I mean, the coding exam, I think you would have got a notification for the coding exam already, right? It would be in 2 different sessions and would be separate from the main exam. In the main exam, you will have MCQ and also numeric answer questions. So yeah. Okay, so let's say this the first question here. So as you can see, this is related to the post and pre-increment operators, which is also another tricky topic. And yeah, we have arrays as well. Okay, so we have defined a int variable a and an array which has 5 elements, 1 2 3 4 5 we have initialized it to. So I'll just write this down. So this is our array, which is 1 2 3 4 5. Now we say that ARR of 1 is plus plus ARR of 1. So what that does? So we are basically pre-incrementing the value at ARR of 1. So this is ARR of 1, right? The second element. So we are pre-incrementing the value of ARR plus 1. So if we are pre-incrementing and saving it again in ARR of 1, so now this becomes 1 3 3 4 5. This is our new array after the first statement. Alright, now what we do is we do a equal to ARR of 1 plus plus. It's a post increment operation. So in the post increment operation, first you do the assignment or whatever other operation is there, and after all that is done, you increment the value. Okay, so here what is the current value of ARR of 1, which is 3 now. So you save a is equal to 3, and then you increment the value of ARR of 1 by 1. So now it becomes 1 4 3 4 5. Okay, maybe I'll write the other way. So this had become this, and this now again became this, and this is ARR of 1, right? This particular element. Alright, now what do we do next? ARR of 1 is ARR of a plus plus. Okay, again post increment, as you can see. So what this basically does is this writes ARR of 1 is equal to ARR of 3, which is the value of a, and then a is equal to a plus 1. Alright, so now what we are doing, we are saving whatever the value of ARR of 3 is. So the ARR of 3 means the fourth element, which is 4. And this gets copied to the place of ARR of 1, and then the value of a is incremented from 3 to 4. But you can see you copy 4 onto 4. Now when you try to print a and ARR of 1, what do you get? You get 4 comma 4, because ARR of 1 is still 4. This got copied here, so this is something like this still. So you get 4 comma 4 as the output. Is that clear? Okay, if that is clear, then let's look at the next question. So in this question we have another a function, and we are using this ternary operator here. As you can see, this is a ternary operator. Why? Because it operates on 3 operands. So it operates on 3 different operands. So this is the if part, this is the else part, and this is the condition. Okay, now that is how the ternary operator works. Alright, now that is inside a function called f, and we have a main function where we have defined a integer variable, which is b. Now we write b equals f of 20. So we are passing the value of 20 here. Now what happens? Ideally you would think that if we write a is greater than 20, so the condition is if a is greater than 20, then return 10, else return 20. Okay, so this is basically what you want to write. So here you pass the value of 20 here, and as you can see the condition is not satisfied. This is false, right? Because a is not greater than 20, so it's false. So you would return 20, and when you try to print b, it would be 20, but that is not the case. So why is that not the case? This is the correct approach. This will work properly. I mean, if you use the if else statement format, it is going to work fine. but using ternary operators is not possible with return statement. So basically the error that you'll get an error, and that will be because of this. The return statement cannot be used with ternary operators. If you want to write if you want a conditional return, then you have to write the if else statement. If you write it in form of a ternary operator, it will not work. It will throw an error. So that is what will happen here. It will give an error because it does not work. Return statement does not work with ternary operators. However, it works with conditional statements. So keep that in mind. This is going to work. If you write it like this, then you will get a output of 20 here. So this will return 20, and when you print that, you will get a 20. Okay. All right. So okay, now I think this is a recursion question again. So we have a function which is taking a single parameter, integer parameter, which is x, and we are defining int y. If x is greater than 100, then we do y is equal to x minus 10. Else we call the function of x plus 11. So yeah, we have to try this out in order to see what exactly happens. It might be a bit complicated. You can also try it on your own and try to answer this. So you give a value of 95 to the function. So I write fun of 95. Okay. Now is 95 greater than 100? No, it's not greater than 100. It's less than 100, so it's false. So now we go to the else part. We go y is equal to fun of x plus 11. All right. Now fun of x plus 11. So when you do x plus 11, that means 95 plus 11, that gives you 106. So we first, so this is what you're basically asking, right? Now if you do fun of 106, what is fun of 106? So if you pass 106, then you will get 106 greater than 100. Yes. So you get a value which is y is equal to x minus 10. X is 106, so you get 96. Okay. Now this value is returned here. Now basically you are doing fun of 96. Now again, when you do fun of 96, what happens? So fun of 96, we put y is equal to fun of 107, right? Because plus 11, so 96 is the input, so 96 plus 11, 107. Now you calculate fun of 107. What is that? So you get a return value of 97 from here, because it's 107 is greater than 100. You deduct it by 10, that is stored in y, so y stores 97, and that y is returned. So you have 97, so that is returned here. Now you calculate fun of 97. Alright, now what is fun of 97? So you have y, when you pass that, so you will have fun of 108, right? Plus 11, 108, and fun of 108 is 98. I mean, the return value will be 98. So this 98 will come here, and you will basically calculate fun of 98, still less than 100. So you go ahead to the next one, fun of 109, right? Plus 11, 109. So fun of 109. What is fun of 109? So you'll have a return value of 99, right? Now basically you're doing fun of 99. Now fun of 99 still it's not greater than 100, the condition is still false. So you do y is equal to fun of 110. You add up 11, 110. Now fun of 110, what is fun of 110? Fun of 110 has a return value of 100 because it's greater than 100. So you deduct 10, return that value, so you get 100 as the return. Now that means you're doing fun of 100. Now just one more recursion, but still this condition is not satisfied, so the recursion will still continue. So fun of what, 11, right? So 111. Now what is 111? Fun of 111, this has a return value of 101, right? Because it will subtract 10, return the value. So this will be fun of 101, but now it has become greater than 100, so it will just deduct 10 and return the value. So fun of 101 deduct 10 is 91. So this will return 91, and 91 will be returned here as the value of y, then it will be returned here as the value of y, then here, and all the way back, and you will get the return value of 91 finally. As when you call fun of 95, you will get 91 as the return. Is that clear? Okay, so let's look at the next question. So this question also has to do with the same thing, which is formal and actual parameters that I explained in one of the earlier questions. So here you have in the main function, you can see you define x and y, which is 1 and 2, and you pass them to this function called swap. The function swap is a void function, so it doesn't return anything. That's what you need to keep in mind. So say x was 1, y was 2. Now you passed it to the function swap. Now a has the value of 1, b has the value of 2, right? Now you save. What the function does, it takes a variable called temp, which is a, that is 1. Now a becomes b, which is 2, and b becomes temp, which is 1, and that is where the function ends. It does not do anything else, so it's a void type. So basically it no return, doesn't return anything. So it just changed some values of some formal parameters, so that this does not change the value of x and y, no change, because it doesn't return anything. So x is still 1, y is still 2. When you try to print x and y, you still get x equal to 1 and y equal to 2. So I hope you understand why that happened. This function did not return anything. This happened because you did a call by value. Now if you had done a call by reference and then you had tried to change, that means you had passed the location of x and location of y, and here you would have changed, like you would have changed star a is equal to star b, that is the values at those locations. You would have tried to change that. Then you would have observed that the values would have been interchanged or swapped as the function intended. But here you are doing a call by value. This passing the reference, that is the location, is called call by reference, and this what you have done here is called call by value. Okay, so any change in the formal parameters will not be affecting the actual parameters in a call by value. Okay, but in a call by reference, if you change the values associated with those memory locations that you have passed to the function, you are going to change the value of the actual location. Okay, alright, so I hope that is clear and has refreshed your concept of call by value and call by reference. So so we can move on to the next question. Alright, so let's see what this question is. So we have an array which is of size 2 rows and 3 columns. Okay, and we set I and j to be 0 and 0, and we run a loop. I is from 0 to less than 2, that means it is taking integers, so it will be 0 and 1, and j is from 2 up till 0, j minus minus, right? And we are printing a of I and j. Alright, now let us try to see how this array is built. So we have an array of size 2 comma 3, and however we have initialized only 4 values. So how will it be divided? In row major format. So I need 2 cross 3, so this should be 2 cross 3. So I'll just put the first 3, 4, then the rest is 0 and 0. That's how arrays are built. It's initialized to 0. Whatever values you don't give it while initializing, it will be initialized to 0. So now this is your array, which is A, 1 2 3 is the first row, 4 0 0 is the second row. Alright, now in the first iteration, let's say I is equal to 0. Here let's look at j is equal to 0. What is j is equal to 2? What is being printed? So you are referring to a of 0 comma 2. That means you're referring to the first row, the third column, right? So you print 3, right? So let me write it in this manner, j2. So a of 0 of 2 is printed. That is the one that is printed first. Then I is still 0, you go to j of 1. So a of 0 of 1. Okay, and what that is? First row, second column. So 2. Now I is 0, j is 0. So a of 0 of 0, which is the first element, which is 1. Now i's value incremented to 1, and again j goes from 2. So a of 1 of 2, which is 0. Then I is equal to 1, j is equal to 1. So a of 1 comma 1, which is again 0. Then I is equal to 1, j is equal to 0. So 1 of 0. So what that is? There's the second row, the first column, value of 4. So this will be your output to this question. And here, as you have noticed, there are no braces required, or no no curly braces required, because you are giving only a single compound statement. So for this for loop, this entire thing is one statement, so one compound statement, right? And for this for loop, you have single statement, that is one statement only. So for both the for loops, you have only a single statement, so you don't need to give any braces if you are working like this. And hence, as you can see, the output will be 3 2 1 followed by 0 0 4. Alright, so if that is clear, let's look at the next question. In the next question, we have the concept, just explaining the concept of strings. So here we have an integer I. We have defined a string a, which is basically nothing. I mean, we have not specified anything inside. Then we are trying to print %s comma a, that is the string a. We are trying to print the string, and that is inside a if else conditional, and based on that we are trying to print if the string is empty or not empty. Okay, now if you remember, in strings, even if you specify nothing, I mean this, we have not specified anything, there is still a null character that will be there. There will be a null character right at the start of the string. So if you write the string array will be /0. This will be a string array here, or rather I shouldn't say string array, it will be a string. This is your string. This is what you have written, that a is the null character. Now this still counts as one character, right? It's a character because null is a character. Now when you write printf statement, so printf statement actually returns, I mean it prints whatever you want, but it also returns the number of characters being printed. So here, or rather number of characters being sent to it for being printed. Okay, so it prints the number of characters being sent to it to be printed. Now here you are sending a string which contains the null character, that means it contains one character. Okay, now if it contains one character, then this entire condition is true, because if of anything other than 0, this is going to be true. If you write if of 0, this will be false. But if you write anything other than 0 there, positive, negative, whatever, it is going to be true. So here it will be if of 1. So if of 1, anything other than 0, true. So this is going to be true. Now if this is true, then it will go and print this statement, right? The string is empty. So it will print the string is empty. Is that clear? So this covers a few concepts here. The first is that every string has a null character. You have to keep that in mind. And the second concept that it covers is that the printf statement returns the number of characters being sent to it for printing, right? The third concept this gives you is how the if and else condition works. That is, if you give any condition inside the if block which is other than 0, which has a value other than 0, it will consider that as true. And if you give something that has a value of 0, it will consider it as false. So all these three concepts are very elegantly integrated together into this one question. So I think this is a pretty good question. You can refer to this later. I think it was in one of the assignments. Alright, if this is clear, then we are going to move on to the next question. So alright, so we have the next question. We have defined an array which is of size 3 and 3. So 3 columns, 3 rows, 3 columns. Now we are trying to initialize this array ARY as this particular thing. We are trying to set the ARY as something like this: 1 2 3 4 5 6 7 8 9, as this. And then we are trying to print 2 of 0, which basically is the third row, first column. So we are trying to print 7 basically. So what should be the output for this? So should it be 7? No, not really. It would actually give you a compilation error. So what do we have to keep in mind while initializing the array? especially initializing a 2D array, you can initialize a 1D array like this. ARR of blank is 1 2 3 4 5. This is fine, this is correct. But when you are initializing a 2D array, you have to always keep in mind that you need to specify the second dimension. The first dimension you can leave it blank. The second dimension is something that you need to specify. You need to specify that, say here it is 3. Even if you are initializing, if you have defined it prior, doesn't matter. If you are trying to initialize this array, you have to mention the second dimension, and then you can write 1 2 3 4 5 6 7 8 9. Alright, so this is what you need to do. The second dimension has to be mentioned. So in the case of a 3D array, the third dimension has to be mentioned. So the last one dimension, the last dimension, you have to mention how many elements are going to be there in the last dimension. That's what is important. So in a 2D array, the second dimension, in initialization of 2D array, the second dimension has to be mentioned. Okay, so I'll just write that down. 2D array initialization mentioned, always mention the second dimension or the size of the second dimension. Alright, always do that. That is very crucial. Alright, so let's look at the last question. So we have a one-dimensional array which is X, which has it has indices from 1 to 50. Now each element is an int, so that has been mentioned, that is important. And the array is stored at the location 1000. Alright, now what is the starting address of X of 27? So that basically the 28th element of the array, right? So we have 1000, so it is arranged in this form, right? So I'll just divide it into int blocks. So the second one, so int means it's 4 bytes each, right? So 1004, 1008, 1012, and so on, it continues up till 50 elements, right? And we need to calculate the 28th, the starting address of the 27, the index 27. So this pertains to, so let me write the index. So this pertains to index 0, index 1, 2, 3, and so on. So when we reach index 27, what happens? So you can just simply write it across. 1000 was index 0, 1004 was index 1, 1008 was index 2. So what will be index 27? It will be 1000 plus 4, right? Because each int is 4 into how many elements? 27. Because that is what you can see. It is a pretty simple formula that you get from here, just because 4 bytes is taken up by every integer, and you will be you are representing the 28th integer here, which and the 27th index. And as you can see, the index 0 starts from 1000, index 1 starts from 1004, index 2 starts from 1008. So if you do index 27, it will be 1000 plus 4 into 27, and how much is that? So you have this is how much is 208, and this is 1000, so 1108. So that is going to be right. This question had, so I took int to be 4 bytes because the question has assumed that the int is 4 bytes. So in some cases they might also tell you that int is 2 bytes. So accordingly you will calculate 1000 if say int is 2 bytes, that is in 32-bit system it's 2 bytes, so it will be 1000 plus 2 into 27, which will be 1054. Okay, so you have to keep this in mind and see if there is any prior data that has been given regarding the size of an int, size of float, and those kind of stuff. Alright, so if this is clear, then yeah, I think this is everything that I had for you. If there are any doubts, you can ask me right now. And if not, then we can probably finish this lecture here. Yeah, and yeah, best of luck for your exams, and probably will. Thank you for joining.